You're all welcome to today's lesson. My name is Emmanuel T. from Nambong Secondary Vocational School, and we shall be looking at mathematics. Here we shall be looking at A-level mathematics, and we're going to be focusing on complex numbers. Now, what are complex numbers? Complex numbers, in simple terms, these are numbers which have two parts, the real and imaginary part. These complex numbers help us to incorporate the elements of the imaginary sections of the mathematical numbers. As we shall be going ahead, we are going to be seeing what exactly yields the imaginary part of a number to make it a complex number. Now, these complex numbers, as we shall be seeing, we shall be beginning by letting our complex number be equal to z. Now, we shall be seeing that a complex number just becomes a complex number by the fact that it has an imaginary part. What's this imaginary part? We are going to begin by letting a complex number be represented by z. As we go ahead with this mathematics, we are going to be seeing that z will be dominating the representation of a complex number. We can call it z, or we can also call it w. Now you might wonder, why don't we call it q, why don't we call it b, why don't we call it a? These are used because we are letting it be. And in mathematics, we don't normally like interchanging things, so that we reduce confusion. Now, what is a complex number z? From the start, we saw that it has two parts. So a complex number z, since we already let it, we shall have our z being a complex number, being equal to a plus ib. Now, that's the complex number z. Or, since we talked about w, it can be w equal to a plus ib. Now, as we go into literature, or as we go ahead, we shall say that don't normally use a and b. You can just use any letter. We can say, for instance, or it can be z equal to x plus I1. This is the complex number. Why? It has two parts. And in this case, we say z and w are complex numbers. Why? Because they are the master functions of a plus ib. This is what provides z and w to be a complex number. When we go ahead on what we've just talked about, that complex numbers have a real and imaginary part. Let's go into identification of these two parts, the real and imaginary. So z being equal to a plus ib. Now let's look at this. There is one part, which is the first part, and also the next part, which is the next part, and for it has ib. We say the complex number qualifies to be complex if it has two parts, the first part and the second part. One part we called it real, the other one we called it imaginary. So what makes a part imaginary? What makes a part real? Now, a real part, we have all dealt with real numbers, anything that can be tangible or can be visualized realistically qualifies to be real from our English. Then imaginary comes from imagination. And what qualifies this number to be imaginary is because this number exists virtually. We have dealt with these things a number of times in science, in physics, and all other parts. So this number exists virtually. When you try to use your calculators and calculate these numbers, which are imaginary numbers, you'll be getting an error. Why do you get an error? It's not because there is any error. No. Your calculator has failed to visualize that this number is imaginary. So that's what qualifies this thing to be a complex number. Why? It has a real part and an imaginary part. So that means that our A is real and our B is imaginary. So let's try to look at what qualifies B to be imaginary. So when we pull out this B, we are going to see that this B of ours contains an I. Now, what is this I? What is that I? The I component here that we're talking about is what brings in the imaginary concept within a complex number. As we go into the literature, we shall be seeing that this I mathematically is equal to square root of negative 1. Now I'm going to give us 4 seconds to get our calculators and we find square root of negative 1. Then you shall maybe comment the answer. So when we put square root of negative 1, and let me give you the 4 seconds. 1, 2, 3, 4. I hope we have put this thing inside our calculator. Whatever you got, just send it into the comment section. Why? You must have experienced that calculator is going to give you error. Not because this number does not exist. This number exists. But your calculator cannot visualize it in this case. Why? Your calculator is in a mode where it can only visualize real numbers. It cannot visualize complex numbers. But when you change the mode to complex, it will be having an ability to visualize this. So I is root of negative 1. And because root of negative 1 is imaginary, it's what qualifies this system to be a complex number. So, ladies and gentlemen, we have now come to the bottom line of why B is imaginary. So it will mean that whenever, as we go ahead with complex numbers, wherever you will be seeing I will be requiring you to visualize square root of negative 1. Why? Because this is what qualifies it to be a complex number. So that will mean that instead of these guys writing z equal to a plus root of negative 1b, wherever there was root of negative 1, these guys were replacing root of negative 1 with I. Hence, they have z equal to a plus ib. And here, we have just come to the bottom line of our complex number. So, ladies and gentlemen, this is a complex number. And why is it a complex number? Because it has an imaginary part. And what is this I meaning? This I means root of negative 1. Now we are going to go deep into a complex number and try to visualize all these. So as we are visualizing these concepts of complex numbers, we are going to be seeing that a complex number originates from somewhere. It's not absolute. We must have been in school and we try to calculate some numbers. These numbers, especially quadratic equations, and you will find out that one of the answers will give you an error. It was hard for you to find the roots of the quadratic equation. It must have happened somewhere in case you try to attempt numbers which are none of your business. But whatever caused that part to lack a value was because you are dealing with a complex system. So we have been saying complex numbers are expressed in terms of a plus ib or x plus iy. So in a complex number, a plus ib. Now this is our complex number, members. A plus ib. We shall be seeing that A is going to be called a real part. It's a real part. And in complex numbers, real parts are abbreviated as RE of Z. Whenever you see this thing, it means they are dealing with the real part of the complex number. For instance, I can give you this, and I'm like, I can give you this, and like W equal to X plus IY. This is what we have. And we say, find REZ. So what we do, since we have just said REZ means the real part of a complex number, and the real part of a complex number is the one without I, which doesn't have an imaginary part. So that will mean that here, REZ is simply equal to Y. Because it's X. We are dealing with real part. REZ is simply equal to X. Because X is a real part of this complex number. Now, we've seen that real parts are abbreviated as REZ. Then what of the imaginary parts, members? The imaginary part of a complex number, we have just seen that for it is IB. Now, IB is called imaginary part. Is the imaginary part of a complex number. And this imaginary part of a complex number is expressed as IMZ. It's expressed as IMZ. Z. So whenever you see im Z, it means we are dealing with the imaginary part of a complex number. And we have already seen that I is equal to root of negative 1. So this is what qualifies this number to be complex. And this part is called imaginary part of a complex number. So if a question comes and they are asking you, find the imaginary part of this complex number, find the im Z equal to a plus ib. Now, im Z will be the imaginary part of the complex number. And what is this im Z? This im Z will be equal to b. Why? Because the imaginary part of this complex number is b. But remember one thing that we talked about. We saw the fact that wherever you see this I will be equal to root of negative 1. We shall have to emphasize this over and over so that we can bring out the whole sense of this part being imaginary members. So that will mean that apart from all this, we can be able to go deeper and investigate what qualifies or where do these numbers originate from. At the beginning of this lesson, I told you that these numbers just have two parts. But you have never been dealing with these numbers sometime back, whereby you had quadratic equations. And we are going to first go through those concepts to remind ourselves the origin of the complex numbers. What makes them complex? So, in the lower class, you studied, there's what they call formula method of finding quadratic, the roots of a quadratic equation. What's this formula method? Some people call it bulldozer. But on that bulldozer method, members, the method is, once you're given a quadratic equation, for instance, we have a quadratic equation of ours there, ax squared plus bx plus c equal to 0. The formula method or the bulldozer method would just be simply written as, for you to find the roots of x, there's a formula that you normally use, and this formula is negative b plus minus root of b squared minus 4ac over 2a. Now, it is from this formula that we determine a lot of dynamics in mathematics. This formula helps us to realize whether we have repeated roots or real roots or imaginary roots. What qualifies these roots to be imaginary? Remember, for a number to be complex, you must have root of negative 1. So, how do we get this root of negative 1? That means that in this case, since we want under root, we should have negative. So what will make this number complex? It is when b squared minus 4ac at least is giving us a negative value. But when we get this negative value, you only get a negative if this is bigger than that. Those of us who have studied mathematics, you know that you get a negative if this is bigger than that. Whatever you're subtracting off is bigger than what you're taking it from. So that will mean that what will qualify this number to be a complex number is when we have an instance where b squared is less than 4ac. So whenever we have this instance of b squared being less than 4ac, we have a complex root. And this is where complex numbers originate from. So ladies and gentlemen, I believe we have had a glimpse of what a complex number is and where it comes from and how it comes to be. So we are now going to be looking at how do we deal with this thing called I. Members, we're going to look at how we deal with this thing called I. And I'm going to look at a number of examples which will initiate us into the process of attempting complex numbers. Members, the day you understand how to manipulate I, you shall be able to do any complex number, whichever way, whatever way. So let's look at this. Examples are over there. You can be reading through them and you can be trying to see what exactly we expect. So let's attempt these examples. The first one is telling us to simplify. They're telling us to simplify. And what are we simplifying? We're just beginning with the simplest. I want us to begin with I. What is I equal to? Yes, some of you are there seated in your coaches and whatever you're doing. I is equal to root of negative 1. That's bottom line. Having us understood this, we now go to I squared. What is I squared? I squared, members, we just do the same thing. We get root of negative 1. We square it. Answers are already there, but I'm going to be showing that's how we come up with these values. Then you shall try out the value that is down that last number. That will be our exercise. So when we square this, we shall be seeing that we are going to be having the square dies with the root, and we stay with negative 1. So I squared is equal to negative 1. So in case you're squaring a complex number, that means that I squared just qualifies to be negative 1. Let's continue. I cubed. So I cubed is the same as I squared times I. Let's do mathematics like nursery 1 people. The same as I squared times I, which is the same as square root of negative 1 squared times square root of negative 1. But members, we have seen that square root of negative 1 squared is negative 1. And root of negative 1 is I. So our answer here will be negative I. So it means that I cubed is equal to negative I. Now that's where complex numbers begin having a magic. But the big deal is us understanding the underlying principle, which is I equal to negative 1 under root. So we got the next one, which is I power 4. So members, what is I power 4? We can ask ourselves. Let's have it also. So I power 4 is the same as I squared times I squared. Those of us who have done math, we understand that. Times I squared. Why? Same base, we add the powers. Therefore we get a 4. But what is I squared? What is I squared? Our I squared is equal to negative 1. So here I'm trying to do it the simpler way, because we're no longer in nursery 1. So this will be equal to negative 1 times negative 1. So members, this gives you I power 4. This is how we continue manipulating these powers of I until infinity. So it means that I power 4 will be equal to negative times negative, that is positive. So I power 4 is equal to 1. I power 4 is equal to 1. Before I go to the last one, I'm going to first give you this example here. For instance, you're given 4. Let me use a smaller number. E.g., find 2 power I. 2I power 4. You don't need to struggle. Why? The static property of powers from indices. So this will be the same as 2 power 4 times I power 4. Now this is why complex numbers are so tricky, because a complex number can easily calculate into a real number. How does it do it? Let's look at this. So this will be 2 power 4, definitely that is 16 times I power 4, that is 1. Therefore my answer is 16. And the complexity of this number has disappeared. How has it gone away? Because we see that I power 4 is equal to 1. And therefore this number loses its complexity. So members, that's how we deal with complex numbers. Lastly, the last example that I'm going to do for us, as you warm up to do that very one assignment that I'm giving you, which is below there. Remember, let's pay attention to this. And this is going to add, complete the icing on the cake. This icing on the cake, I power 5. The same process, same as I squared times I squared times I, which is negative 1 times negative 1 times root of negative 1, which is the same as 1 times I, which is the same as I. So I power 5 is I. So ladies and gentlemen, this brings us to the real view and understanding of a complex number. I believe this has been so instrumental for us coming to comprehend what the complex number is all about. Below is a tryout question, which is going to be attempted by you. It's over there on your screens. It is I power 4 plus I power 8. This lesson is going to stop here for now, and I believe to see in the next lesson as we expound more about complex numbers. Thank you.